ready. And to go live. Mic check, 212. Mic check, 212. What it do? Boo boo. Okay. We good over there, buddy? All right, good, great. What's going on, guys? So, welcome to episode 57 of the Swift and SwiftUI Learn Along. My vast and endless apologies for starting late, rather late today. Normally, I'm a bit more polite and only an hour late, but today I'm multiple hours late, getting some stuff sorted out with the new home and all that jazz. So, yeah. And to that point, the stream will probably be around this same time tomorrow, and then we'll get it back into the mornings because I'll also be moving tomorrow. So that's that. And just generally speaking, if you are new to this, if you never been here before, brother or sister, let me just give you a quick lay of the land, if I can remember Excalibur, right? Excali, there we go. Let me just talk you through what we're doing here. So, how can I? Yeah. Okay, so just following the arrow here, right? So first we started with Learn in Swift, and we went through a book called The Big Nerd Ranch Guide. Okay, great book, highly recommend it. No affiliation, just learning it. That was, so like I said, we're on episode 57. The first 45 episodes, which is roughly 120 hours of content, covered that book. So if you want to get caught up, you can go to YouTube, and on this channel, Nico X Narration. Okay. If you go to the live section, they're all recorded, all the streams, and they're all in succession. They doing out there, falling off the damn roof. They're all in succession, so nothing was done off stream. So we just literally just go through the book. And to that point, I am not teaching you. You are learning along, as in I don't know this stuff either. So can be a bit painful at times, but just know what you're in for is really the point. It's just the raw learning process. So I'm not regurgitating things that I already know. I'm actively trying to learn them. And currently, like I said, we finished Swift, right? Now we're on SwiftUI, which I'm excited about. We just started this yesterday because we found yet another book to move to, because this one, and I checked last night, is finally, it's the modern hero that we needed. Just put it that way. Okay, so the first book we were going to use was The Big Nerd Ranch, but come to find out that has been updated since 2021, so it's using a lot of UI kit, which we don't want to do. We're not learning UI kit here. Okay, this is we don't have anything against Objective-C and UI kit storyboards or core data. There's nothing against you guys, but we're not learning that here. Okay, it's a Swift and SwiftUI stream. Okay, I just don't want to learn it. I have no reason to. I would say that it's probably actually a great idea to learn it if you just want to be an iOS dev or any Apple platform dev. It might be good for you to learn that, because if you're going to go work for a company, more than likely they have, not everyone's going to rewrite all their shit in SwiftUI. So that is true, except that's not my scenario. This is just a more or less a passion project, and yeah, I mean, I'm building a thing for my company, and so it'll just be me and my wife to be writing this app. So we don't want to learn Objectives. We don't want to learn the old ass shit, the old frameworks. Pardon my French. Yeah, so just understand that. So we're gonna skip that part. But anyway, we finally got to a point where I found yet another book, and it was using SwiftUI, but then it wasn't using Swift data, which apparently is yet another. It's a data framework for using and accessing data, reading data, stuff like that. But the predecessor to Swift data was core data. And that's what the other book was looking at. And so finally we found this Big Mountain, what is it? BigMountainStudio.com. Yeah, and the great thing, this is how I know it's meant to be, because why I'm so excited about it. Literally on the, because one of the concerns I had about doing these streams, I didn't really have a concern initially just starting, because I know obviously no one knows who the hell I am. But my concern was that, putting course material on a stream, I wasn't sure of the ins and outs. Like, based on what you go read, fair use and all that, if you're narrating over it and you don't show the whole thing, you could kind of technically probably get away with it. But if anybody were to directly alert the author of the other book, which was Codeco, they probably wouldn't like that. You know what I mean? But anyway, the good thing is Big Mountain Studio, it literally says on the site, if you want to use this to make content about how to learn SwiftUI, go for it. Just shout us out. So, brother, thank you so much for that. Or sister, I don't know who you are. All y'all at Big Mountain Studio, good on you. Much appreciate that. Go check them out. And also, this is in fact the their content. So that's what we're going to be learning from. And yeah, I'm excited because not only does it use all the up-to-date frameworks and whatnot, Swift data and strictly SwiftUI to show us how to build apps. I mean, look at these nice little pictures. So I mean, there's 600 pages of it, but a lot of it is images and whatnot. So yeah, I mean, this should be pretty easy learning in terms of ease of use, especially if you've kept up with the since the beginning of the stream, because we just got done learning all the primitives of Swift, Swift proper, just everything about Swift. Literally covered all the components, save for maybe concurrency and like deep dive into compiler control statements. But other than that, we dug in pretty deep. So yeah, let's get to it. Oh wait, I didn't finish mine. Okay, yeah, for the newbies. Yeah, so after we finish this book here, then we're going to get the web server API and the local onboard storage schemas set up. So I'm going to use GraphQL for the web server, just because I like it, and then SQLite for the onboard storage. And then after that, we're just going to be working on alternating between, actually building the app. So my app's name is going to be MRP Panda. My customer, well, we'll talk more about the business stuff later. Plenty of time for that. But yeah, I also want to, sorry, scratchy throat. I want to finish I started a brief journey into learning C. And so I want to finish that out because I know it's just the skill I want to have. I don't know how else to say it, but yeah, so we're going to be alternating between, just actively working on the app and learning C / learning how to interact with C libraries through Swift. So I thought that'd be a good synergy there. But yeah, if that sounds good, please drop a follow. If not, get the hell out. Okay. All right. So now we can start. Now we can get there. Okay, we're not writing any code yet, I don't think. So I'm just going to make this bigger for now. But eventually we will be. Okay, so yesterday we got through chapter 1 or part 1. I think this is, yeah, this is where we left off. But actually, give me BRB. Give me 4 minutes. No, we'll start in 5 minutes. I just need to run to the restroom, refill my water, and get another energy drink. Moving is just stressful and all that stuff. Okay, be right back. Oh, forgot my. Ooh, baby, I love your way every day. 1, 2, 3, 4. 1, 2, 3, 4, 5. If you know that reference, you're old. Damn, you're old. Just like me, brother. Okay. I feel ready. It is time. All right, tools for persistence, a Swift data concept. Oh, and by the way, so they gave us some projects, sample projects. I've already got one loaded. I'm not sure, we'll take at least one end to end, but this book is being taught through the lens of Swift data as the focal point, which I like. So, but just FYI, because I know it might be a little confusing because yesterday we were on a whole different book, but that HIT app, the workout app that we were working on, that's gone. Forget about it. Okay. Okay. All right. So, and previous to this, all we did was cover some concepts about the generalities. But yeah, you can watch the tail end of yesterday's stream for that. All right, now tools for persistence. When your app has data, you have to store it someplace where it can persist so that when the app is closed or the device loses power, it won't disappear. Yeah, that makes sense. At the end of the section, you will know more about data persistence and how it fits into Swift data. This is getting on my nerves. Okay. The toolbox. Persist means to continue to survive or exist. If you close your app or turn your phone off, the data will survive. The second part, the toolbox, has to do with tools to read your data model. And with this knowledge, it can retrieve and persist your data. Okay. So we have the model. Yeah. Okay. So the model is the definition. The model would be, whoops, like this, literally in a directory per their recommendation, in a directory called models. But yeah, this would just be the formation, our types basically. These would be most of our types, maybe some. I guess it really would be all classes. Yeah, it looks like they are. I think that's the SwiftUI protocol. So, but that's fine because it's the framework and it's declarative, so we won't complain. Because I know I bitch and moan a lot about not using classes in the business logic, and we won't. But for SwiftUI, that's take it or leave it. So we're taking it. But yeah, these are all examples of models, and we briefly in the other book learned about these directives here. Kind of giving me TypeScript vibes, but yeah, this would be an example of the model represented in syntax. So just a type. Okay. So that, why, man? Okay. Okay, so that's a model. And then the toolbox, which, oh, okay, they told us. I was gonna say I don't know what that is yet, but second part, the toolbox has to do with tools to read your data model, and with this knowledge. Okay, so that's what we're going to learn. So that is Swift data in this case, or that would be the framework we would use. So that would be our toolbox. The playground is, what is the playground? I don't know if they mean literally the playground. Like these are in Xcode. .playground is a file type, kind of like a Jupyter Notebook on steroids, but it's really awesome. I'm not sure if that's what they mean by that though. And then the view, okay. The view, of course, where we actually interact as end users, interact with whatever the program is. Okay, when an app saves data, it will store it somewhere so that data can then persist. Even when, why do I have the hiccup? Excuse me. Even when the power is turned off or the app is closed. Apps on your iPhone are stored so they can persist if your phone loses all power. All iPhones have a physical component that can store apps and data. Yep, and many wish it was a bigger physical component. You 128 bastards. Okay, storage with power. A storage device like a solid state drive. Data. Okay. Storage with no power. Data. The data still persists. Indeed. Okay. Swift data will store values to the physical storage on the device so it can persist after closing the app or shutting off the device. Model container. Swift data uses the model container to store data so it persists on the device. Uses the model container to store data so it persists on the device. This is the toolbox. Oh, okay, so I was incorrect. This is the toolbox? The model container has quite a few tools we can use. Okay. Store data. Oh, okay, so it's responsible for writing to the disk. Okay. Maybe Swift data is one of many types of model containers, perhaps. What does the model container do? Reads your data model and sets it up for use. Controls where your data is persisted on the device. Ooh, did y'all hear that? God damn. My damn head's gonna fall off my shoulders. Is responsible for loading up your data from the persistent storage so your app can use it. Is responsible for loading up your data from, oh, okay, yeah. There's more this awesome toolbox can do, but let's keep it simple for now to get you started. Okay, great. Let's see. Now, container. What are you? Think of a container as a box that can hold many things. Okay. A container can hold tools, food, pencils, etc. In programming, containers can hold a collection of other objects. Like Docker. The model container is like a toolbox container that will provide you with almost every tool you might need to work with Swift data. That will provide you with almost every tool you might need to work with Swift data. Okay. I guess it's worded that way because it's a Swift data is just a library. I don't know. I wouldn't have thought of it like that though. Anyway, model container and then all the relationships. So tools to load your model, tools to read and write, tools that create a space for you to change your data, tools for working with mock data for preview in SwiftUI. Well, when you look at it that way, it does seem like a framework. I don't know, fucking know. Many of these tools used to be separate. Developers had to do a lot of setup work to make them all work together in the past. But Apple developers made Swift data easier to use with the model container. Okay, just what? Yeah, there it is. Check this out. This is pretty cool. What is the difference between shifted? Yeah. Oh shit, it's right. I didn't even tell it. I got ahead of myself. But yeah, isn't that cool? See this app called Mac GPT. You can give it a little sequence of characters. So I chose \GPT, type out something, and then you hold a certain key combo. So mine is Shift Enter. And then it just goes and makes an API call. And as long as you're in a native text app, so basically any app that's native for Mac OS, it'll just write it out. It's pretty sick. I'm mad at OpenAI though, but I still have some credits to burn, so I'll keep using it for now. Okay, what was I saying? GPT. That's not what I want in there. In Swift, what is the difference between Swift data and what? All right, whatever. Never mind. What do you mean it's not? It must be set to oh my god. You know what? Just forget it. We'll just keep reading. Holy shit. All right, think of a container as a box that can hold many things. A container can hold tools, food, pencils, etc. Oh, I read that already. Many of these tools used to be separate. Okay. I did not advance the page. All right, model plus data values equal data objects. Your model, get here. Your model and the actual data values are two separate files. The persistent container and its toolbox will merge the two together. It always gives you the data as defined in your model, so you have data objects you can now display and work with. Oops. Okay. Your model and the actual data values are two separate files. The persistent container and its toolbox will merge. It always gives you the data as defined in your model, so you have data objects you can now display and work with. So that's just a text file? And this is a data object. Is it creating the code for you though? I guess that's the part I don't get, but I guess we'll find out. I mean, because you could also just write that as a, like that's what. Let me show you an example. Preview content. Yeah, so any of this mock data would be an example, but you can just give it like whatever this friends GD. Like somewhere there should be, yeah, okay, here we go. I guess that is it because it's making this little container call. Okay. So, I mean, literally just stored in text somewhere. But I assume they mean that this file, like the source code itself was not written but generated by some tool, combining the type and the raw data from elsewhere. Is what it seems like it's saying, and that's okay, that's cool. Why isn't this part in the flow? I intentionally left out the data values from the flow because you don't have to do anything to get it working. The flow. Oh, here's the flow. Model. These are just models, no data object / values are here. Okay, so the model is just our raw types. Okay. Now that Swift data knows what the data will look like, it needs tools to read and store the values. Okay, I guess that's the answer because here the toolbox encompasses Swift data. Yeah, so it seems like Swift data is just some component of model container, kind of like how core data was. That would make sense. All right, so then where were we? Part 2 in the flow, model container. When you start your app, one of the first things you want to do is instantiate your model container so it can read the data model and then your persisted data and get it ready. Okay, so model. Did I have an arrow? I thought I had an arrow thing. Yeah, okay, that's better. Okay, so model person. The model container uses the toolbox to read the model. Yeah, so that must, okay, so this is a library. It's got to be. As part of a SwiftUI, reads the model. The data on the device will be loaded up and ready for the next step. So it reads the disk here and then feeds I guess writes it into memory in some form or fashion, the playground. Now for the next part, this is where data object fetches and changes are managed. This is where data object fetches and changes are managed. Fetches and changes. So this is the disk, and then yeah, okay. So that makes sense that would be at runtime or whatever, and then the view that the user uses to interact with it. All right. Managing data objects. Once Swift data understands the data models and where data is stored, it can retrieve and give data objects to your app. At the end of this section, you will understand more about how and where data objects are managed. Hell yeah, brother. The playground. The third part. Okay, I was just impatient, my bad. Because it's like literally telling us what all this is. We need a playground. I have to apologize to you. We need a playground where we can play with data. Many times after fetching data, you enable the user to insert new data, change the data, delete the data, or maybe undo changes. This is where your users will do it. I see. So, okay, so that's runtime. The playground is runtime. Where the data objects, the things with actual values, are managed. Got you, brother. And then the view. Okay. So the user's coming in through this way, but ultimately the data is here. And then, yep, see, makes good sense. All right, memory. When any application works, oh, I just want to make this a hair bigger. Can it get just a little bigger? I guess not. I guess that's fine. And the grammars can't see it though. Okay, so when any application works with data or data objects, it is usually done in memory or RAM, random access memory. Memory is temporary, so if the device loses power, all the data that is in memory is gone. It's true. It happens. The operating system gives your app memory to work within. When you close the app, the operating system reclaims it and any data within is gone. Unless you have Microsoft Recall. Memory with power. Data. Memory with no power. No data. Swift data will use memory to temporarily store data changes. This is useful in case the user changes their mind and decides not to save changes or deleted data. Undo. It is also useful because memory is super fast. Boy, is it fast. Model context. Swift data uses the model context as a space to let you freely change data in memory. Really? What? It sounds pretty hardcore. Swift data uses the model context as a space to let you freely change the data in memory. It is where updates, deletions, and the creation of new model objects take place. I guess every language does that though, so it's not that hardcore. You manage your data objects here. Remember, data objects are just data models that have values. Your data objects are just data models that have values. They're your models that have values, but they are not the actual data until you execute some kind of action against disk. Yeah. Okay, model context in memory. Fetch data, change data, deleted data, new data. So it's all kind of in this holding cell. And it has the potential to be authorized to be saved to disk, but you can't make the assumption, so yeah. Note, all of these data object changes are just in memory. Swift data will automatically save the changes in memory to your persistent store. This is done by default, but you also have the option to turn this off. Wait. This is done by default, but you also have the option to turn off this feature so you can manually say when you want the save to happen to the persistent store. Okay. But the persistent store, I think that's it's still in memory, right? They're not talking about. And Swift is the persistent store. Yeah. Control E, yeah. You know what I just realized? The AI won't even. I'm just so used to it because they updated it for. It might be even more up to date now, but I know at one point they got them as recent as April 2023 or whatever. But this is Yeah, okay. So it's not going to know what Swift data is. I was wondering, I was like, what the hell are you talking about? But okay, yeah, I just thought of that. So, okay, well, then you're of no use to me. All right, so Swift data uses the model context as a space to, okay, we read that, yeah. Yeah, it should answer the, okay, there we go. Model context. The word context means everything related to some event or idea, so you can make sense of what is being said or shown. It's a good definition. When you have data objects in memory, the operating system has to know what this memory is related to. Is it for app A or app B? Yeah, I always struggled with, because I wrote Golang briefly. I'm a SQL guy. I love SQL. Wrote SQL for like a decade. Mastered that shit. But Go, not so much. And yeah, the context thing, that always, what a bumpy ride. But yeah, Swift is much more elegant and much more excited to write Swift than I was with Go. I can tell you that. All right, so context lets people and computers know how the things in memory are connected with which app and what they're used for. One app can have many contexts being used for different purposes. Right, yeah, because in my experience with Go's context, it was mostly reasoning about, lambdas and switching between different channels for what's called that big ETL framework, Spark. Yeah. What a pain in the ass that was. Okay, so iPhone memory. So I guess these can all be viewed as some kind of container within the total like 8 gigs or 16 gig, however much are in our iPhones these days. So these would be 2 different apps that are open. And then within that subcontainer, the context for whatever the data objects are relative to that application, images or audio files, video files, text files. So the context just means this data is related to this app. Okay. If your app works with drawing graphics, it will need some space in memory to work with that drawing data. So the context just means this drawing data is related to this app. No, there are many contexts for many frameworks and technologies within the available libraries used for developing apps. Here you see examples of data and drawing context. When you see context, think space and memory to work within. Okay, yeah. Great. I like that definition too. Why can't I highlight this? Weird. Okay. Oh well. Actually, I just want to screenshot that. I didn't realize you could use Notability on macOS, but it's like a full port, which is awesome. I love that app. So now I don't have to secretly complain about Bear anymore. I can just use Notability. So that's pretty cool. Okay, yeah. God dang, sorry. Frog in my throat. Model context is from the model container. The model context is one of the tools provided to you by the model container. The model context is one of the tools provided to you by the model container. I will give you a place in memory context where you can make all of your data object changes. Let me know when you are done, and I will save all your changes to the store. So saith the model container. Okay. So based off our data models initially, it reads those, and I guess that'd be the equivalent of its, of it laying out our little box without anything in it initially. Because it knows, well, the compiler would know. So we would have our data models, the compiler would assign the amount of memory required. So then model container would know how much space to either, or not either, just to pre-allocate so that we can initialize our app. Yeah, that's what it'd be. Yeah, so that would always be there as soon as you start the application, and then I guess in a fluid state, it'll either be writing or deleting or changing stuff here within that context. Okay, makes sense to me. Part 3 in the flow, the model context. The model context is provided to you by the model container. It is giving you a space in memory context to work with your data objects before it saves that data to persistent storage. Okay, so definitions. Reads the model. Reads the disk. Writes data into memory, into our context. So this would be the playground part. Because whatever is here isn't saved to disk yet, or even in the store. It's just available for viewing and, oh yeah, that's what it's saying here. Yeah, the view of fetch data allows editing, deleting, and inserting. So it takes whatever's here, then based off what the user does, I guess it keeps in a separate pool here, change data, deleted data, new data. This is memory space to work with data changes. Dang. And then the context. I guess this is happening in parallel though, all of these different actions, whatever would affect the data. And then this represents the writing back to disk or committing your changes if you're from the DB world, brother. All right. Yeah, weird. There's so many layers to it because even when, well, I guess the only difference is like here in this step, there would be a web call. It's like a whole other server, and then like the iPhone. But yeah, the exchange is still the same. There's just more steps, but yeah, okay. Yeah, I mean, that didn't really change for any client server action. So, all right, so the view. It is the view that queries data to display. Before this can happen, you need to set up Swift data to be used. When your app starts, there is a particular order in which it initializes Swift data for use. At the end of this section, you will have a better understanding of this order and an idea of how views work with Swift data. Okay. the view request data. The model context is not automatically filled up with all the data from your persistent store. Okay, wait. Automatically filled up with all the data from your persistent store. Okay, then never mind then. That answers that question. So the persistent store is the disk. Has to be. Because this is the context, and now we know it's just a place in memory. They're saying it's not all loaded there immediately, which makes sense. It's just what do they call it? Lazily loaded, so just on demand. So this is the disk. Container is the disk. Okay. Okay, I need data. The request itself would go through the container. The container provides provisions to load from the persistent store into the context, which is memory. And then through bindings or whatnot, however we, at least in SwiftUI, through our bindings, it's then represented in the view, and the vicious cycle continues from there. Okay. Model context and view. The model context is a temporary place where the view can query, create. Oh, by the way, if you're wondering, and this just popped into my head, if you're wondering, we are going to be writing code. I guess it's just more of a, I looked ahead because I was like, is this all just slides? But yeah, for now it is just slides, but I find it helpful. But just, yeah, we are going to write actual code and put actual code against these concepts. So no worries there. Okay, back to it. The model context is a temporary place where the view can query, create, change, and destroy models within it. The state of the data is synced between view and the model context automatically. When you change the data in one place, it updates the other. Okay. Yeah, I want to know what it meant by those text files, though, or what it's doing there. Okay, so from the view, when we save changes, in Swift data, you can manually tell the model context to push changes to the persistent store, or it can happen automatically. Yeah, it's like if I'm in like this app right here, right? This thing that I'm working on, this Notability app. This is a file somewhere, but like right now, or not, this isn't a good example. That's probably already saved, but whenever you're like actively inside a text box, I guess that at this point, it would have to be somewhere in here. And then maybe it's, I guess it's saying you can decide, but it can either automatically, so like, I guess on every edit almost, or after every character or a couple of characters, I don't know, whatever the rules around that are, if you let it do it automatically, it's just constantly updating that file, maybe, or just doing it on a schedule. There's probably some optimizers there that, you know, like wait for 2-3 seconds of inactivity on an object and then, you know, write it, something like that. But yeah, I think that is right. Yeah, okay. All right, yeah, that makes sense. Loading Swift data. The last piece of the puzzle is the app itself. when the app starts, you will create the model container first. Okay. This is a simplified idea of how it all works, so you can think with it. You will learn more details about each of these parts and what the code looks like in this book. Don't worry, it is simple. Okay, the app starts. I love these illustrations. If we can't learn it from this, brother, we might as well. Go to the nearest, nearest dock and just start hauling fish. But we got it. All right, the container is created. The models and data values are read. So presumably that's from our, already compiled app. Or from the bundle. Or no, that would be compiled. The bundle is just for assets. And then it writes data into memory lazily. And then finally, data objects values are created by the model container and loaded into the model context when queried. So, okay, maybe I'm thinking of it as too broadly, because this sounds like it's just like a dev tool. Because saying objects or values are created. I mean, I know it can read data too, but I'm wondering, yeah, that's what it seems like. Using at environment, which is a macro based off that syntax. A common practice in SwiftUI apps is to store the model context in the environment. This way it is available to all views, so you can fetch and save data. Is to store the model context in the environment. I'll be eager to understand what that means. Where else could it be? I don't. So here's the environment, which is represented by memory. Yeah, these little RAM sticks here. And so that encompasses data objects, persistent store is here, and then, okay, so is to store the model context in the environment. That way it's available to all views. Okay. SwiftUI has some super easy ways to get data and display it. Saving your changes is also super easy, in most cases automatic. Maybe it's just I'm overthinking it because it's overly simplistic too. But I mean, maybe it's not as obvious to some folks, but that's probably the case. It just, to me, like, where else would you put it otherwise? How could it even be separate? You've learned a lot of concepts around Swift data. You'll be using these throughout the book. Okay. So in summary now, if you were to ask me what is the main part that makes Swift data work, I would say it is the model container. Everything you do in Swift data revolves around this one main part. Okay, yep. Reads, stores, and writes to memory. And then the view. Yeah, that's why I always get so confused when it's probably one of those terms that gets conflated a lot, but when they say Swift doesn't have a runtime. Okay, the flow. Well, I say that I know it has a runtime on macOS for sure. For what's it called, to interact with Foundation, all the NS stuff. But yeah, each of the 4 parts all has its own responsibilities. Model. Describe what your data looks like. Specify how it might relate to other models. So aka our schema. Then the container reads the model, loads data. Model context loads up with data models, tracks changes, provides tools to undo or commit your changes to the persistent store. And then the view, the app creates the model container, loads data from the store. Views will sync with model context, where users perform data changes. Yeah. First example. In the previous pages, you learned about the 3 main tools the app needs to work with Swift data: model, model container, model context. Okay. You should have a pretty good concept of what they are and how the app uses them. I do, but in terms of what they are, not really. I'm just going to call it a framework. That's what it seems like it is. Okay. You should have a pretty good concept of what they are and how the app uses a model container is created on app startup, reads in the model, and provides you with a model context for Swift data operations. Now you're going to learn what those concepts look like in code as we set up a model, create the model container, add some data, and show it in a SwiftUI view. Okay, great. Everything will be answered. At the end of this chapter, you will have a working Swift data example. Yeah, brother. Okay, so now I must move you aside. Close you. Okay. Chapter quick links, setting up the model. Oh, okay. This example will take you through creating your first example with Swift data. You can use it on an existing project or a new project. If you create a new project, select none for the storage option. The Swift data option will auto-generate a lot of code that can be confusing when first starting out. We're going to make it very simple. Okay, then I will close this one for now. Close. Oh, whoops. I have to show you guys this tool that's in the background here at the end of the stream. I'll just say it's so good, it made me reconsider even putting in the effort to finish learning this and just using the tool because, yeah, but I'll show it to you. It's expensive though. Oh, app. macOS, does it matter? macOS. Next. Big mountain. Storage none. Okay. Okay, new or existing. So we did a new one. Swift data did none. Okay. Example, project organization and setup. Views. and models. Okay. How do I make a, oh, there we go. So group models. You can create two folders, models, views. Yeah, so in this, just so it's said, in a lot of the literature, it talks about, you know, a SwiftUI view or a model, but they're all .swift, just to be clear, because it was a little confusing for me at first whenever, like if I go to start a new file, the difference between choosing a Swift file and SwiftUI view is it's the same file extension. SwiftUI view just comes with some boilerplate that the Swift file would not. That's literally it. So they're the same file type, and they can, you know, based on what you write inside the file, it can be considered a view or not. But yeah, they're the same. They're all .swift files. Just FYI, whenever they're talking about these two different terms. So the SwiftUI view just has some boilerplate already there for you, like this stuff that you see on the screen. Okay, so separate the views. Next, move content view into the views folder. Content view into views folder. Rename to first example view. Okay. Where is what is happening? Why can't I rename it? The heck? It's pretty ghetto, but I'm not sure why. Where's... Yeah, that probably wasn't a good idea. File, let me just close that real quick. Whoops. Okay. It's probably the worst way to change the file name ever. Okay. Did reopening help? It's probably some permissions thing. I don't know. Whatever. Okay, continue on to create a Swift data model. All right, so we got that set up. By the end of this section, you will learn the basic creating setting up a Swift data model in Xcode. When you add a new file to your Xcode project, you can just select Swift file. There is no special file template for a Swift data model. What should I name the file? It is really up to you. You may find it easier to just have one file for all of your Swift data models and name the file models, or you may want a separate file for each Swift data model and name the file the same name as your model. Well, we did it the separate file way on the other examples, so I think with the right shortcuts, I would prefer one big file. So we'll try that. See how that goes. If not, we can just break it out. All right, so we file again. Swift. And we will just call it models. Okay. For this Swift data model, call it person model. As a convention in this book, I'm going to add model to all model files so I can quickly identify it as a Swift data model. Select the models folder when creating new Swift data model files. Well, now I feel compelled to change it, but I'm not gonna because I don't know how. And I don't want to do all that shit again. It's really weird. It's not. Maybe I need to run build. Why that would matter? I have no idea. Oh, okay, here we go. It's so weird. Okay, well, we're going to leave it. We're not going to use person model. Okay, let's create the Swift data model class. Importing Swift data. Since Swift data is its own framework, there we go. You will have to import it so you have access to everything within that framework. At model, for example. Okay. Do we also need foundation? Doesn't look like it. So delete that jazz. Import Swift data. Okay, and then this directive thingamabob. What is this? No quick help for app model? How's that possible? All right, fine. That's surprising though. Class. Oh, person model. So 2 mutable variables here. 2 properties. Age of type integer. And name type string. And a custom initializer. Custom made, really. First parameter is called age, and we want to pass it an integer and I forget what they call it. Yeah, default value. I thought it was stored property, but that's for, I'm thinking of inside the variables. But so then whenever somebody calls this, it'll just default to 0 is what we're doing here, the equal sign 0. But they can still change it if they need to. Name. Oh yeah, right. But also, I think that also lets you call it without even defining age, and it'll still let you do that because it has a default value. Yeah, okay. Second parameter, name, and that'll be a string. Makes sense. Default value, empty string. Then we open up the body. We use little self, not capital S self, but little s self to refer to the instance itself, self, which just means whatever we pass in, we want to use to then populate the variables in our model up here. Self age equal age. Self name equal name. All right. Do I always need an init? And the answer is no. Well, in just regular Swift, because at least in regular Swift, it'll give us the member-wise initializer. is what we learned. Do I always need an init? Can I just provide default values on the property instead? You will always need an init when you use @model because it requires it. Oh, there you go. So this is a special case here. So I suppose somewhere under that directive of model, there would have to be a protocol enforcing, a Swift protocol enforcing that somewhere. Okay, even if you provide default values for your model properties or make them optional, an init is still required. Yeah, okay, so it's definitely coming from a protocol somewhere. Note, you can provide default values on the parameters inside your init. Yeah. This gives you the option of creating new models with minimum data passed in. Yeah, so if we do that, then we could just, do that and get a new instance of that thing, var thing equal an instance, and then we don't have to pass any of this stuff. It would just assume 0 and an empty string for thing. @model. The @model macro tells Swift Data to use this class to create the persistent storage with these property names and types. Oh. Shit. I see what it's doing. Okay. So that's the difference from earlier, from my rambling earlier. But I was just wondering what the difference in this was. And it probably, it won't be here. But a few episodes back, we looked at the preview data and actually wrote extensions to have data to work with when we were in debug mode. But this takes it a step further. So the way that we first saw it done was if we only needed no persistent storage, we just wanted to populate the context in terms of what we saw here. You could use those, we wrote it as an extension to a type, and we just literally typed in, the array values, and then just called them in the preview. But this takes it a step further, and whatever is defined, it also writes it to disk. Okay, so then you have, okay, that's cool. Can I use a struct instead of a class? Yeah. No, you cannot. Just like you cannot use a struct to create an observable object. This is because @model also makes your class @observable. Yeah. Your model is fully observable now, and your SwiftUI views will automatically update when the model values change. Yeah. But what we did learn is that does not necessarily mean, like, we can still avoid inheritance in terms of if we use SwiftUI, we don't have to adopt any of that. Everything's handled by the framework anyway, so we're just interacting with the interface. So they're probably doing some form of it, but that doesn't matter. But if we use SwiftUI, we don't have to introduce inheritance in terms of business logic. So that's fine. I mean, it's whatever. First example, model types supported. Simple types, bool, data, date, decimal, double float, and string URL and UUID. Oh, that's all I need, really. Arrays. Oh, wait, I need those two. Enum structs and custom types. As long as it conforms to codable protocol, which we did cover to some extent. Yeah, this looks like basically everything except for prototypes, but that's not right. Yeah, I guess it would be a complex type, but whatever. Obviously, they can still be used to enforce things that affect the use of Swift data, so it's kind of one and the same. What kind of types can I store in a model? I divided up the types. you can store in Swift data into two categories: simple types, complex types. This book will show you how to work with all of these types listed here. Sweet. First step done. You added a file and defined a Swift data model class using @model macro. Step 1 is now complete. Hot dog. All right. Step 2. I don't know if I have time to. Today's been ravaged by yeah, I think we'll probably wrap here because I have to go get a workout in, and I gotta come back and start the other stream. So yeah, we'll call it there, folks. Sorry for the erratic nature of the timing today. And if you didn't catch it, we'll probably start later tomorrow too. So I'm moving tomorrow, so probably 4 o'clock-ish again. And then we'll go back to morning time because I'll be settled in at that point, provided my those damn internet folks get out there on time. But yeah, guys, thanks for tuning in today. Check out my other stream, 9 p.m. tonight, possibly sooner. A Halo stream if you want to watch a sweaty nerd yell at other sweaty nerds and pontificate about stuff. But otherwise, I will see you tomorrow. Please drop a follow and follow me on X. Okay. Take care of yourself. Damn it. Take care of yourself.